Right, number 21. A circle with a chord AB is and its perpendicular bisector CD is shown. So perpendicular bisector means right angle and cut in half. The measure of arc AC is 28. So A to C is 28. What is the measure in degrees of B to D? So a couple things we need to pay attention to on this problem is that from D to C, I can see it's going through the center of the circle. So that's a diameter. If I cut a circle in half, I know there's 180 degrees total. So on this side of DC is 180 degrees, on that side of DC is 180 degrees. So if I already know 28, I'm going to take 180 and minus 28, so I know that this part's 152. Okay. One of the things you have to remember is that when you have a diameter and it's the perpendicular bisector of the chord like this, that the two little arcs are going to be exactly the same. Okay, these little pieces are the same size, these little arcs are the same size. So if these arcs are the same size, they're both 28, these arcs out here are both the same. They're both 152. So I have everything labeled. I need to know from B to D. From B to D is 152. Okay, so you just have to remember that property, that if the chord gets bisected like that, these two little arcs that are created are also the same size. All right, number 22. We've got triangle XYZ is transformed to create triangle X prime, Y prime, Z prime using this rule. So this rule is saying I'm adding something to X and I'm adding something to C. Now, if you want to draw a picture, you can. You don't have to draw a picture. Okay, we just have to match up these coordinates. I'm looking at these X values for point X, these X values for point Y, and these X values for point Z. I'm asking myself, how did they change? I went from here to here, from here to here, from here to here. I subtracted 4 every single time. So if I'm using this pattern, I'm subtracting 4 from my X value. And now I want to do the same thing for my Y's. So I'm looking from -2 to 5. What did I do? From -4 to 3, and from -4 to 3. I added 7, I added 7, I added 7. So now this is going to be a 7. So there's not really a picture necessary to do this problem because they're lined up pretty well and you can just see how did it change. You don't have to put it on a graph. If putting it on a graph helped you, draw a picture, count the spaces. But for translations like this, you can just count since both sets of coordinates were given. For 23, it says a tile is in the shape of an isosceles trapezoid. The tile is divided into 2 parts by its mid-segment. The trapezoid with lengths in centimeters is shown. The top part is shaded. What is the area in square centimeters of this shaded part? So mid-segment is something important to remember. When I find the mid-segment of a trapezoid, it's the average of the 2 bases. Okay, average of any 2 numbers, you take them, you add them up, and you divide by 2, right? There's 2 bases, adding them up, divide by 2. So if I add those up, I get 18. 18 divided by 2 is 9. So this piece is 9. Okay, mid-segment means I'm connecting the middle of each side. I don't really need that though, because when I think about my area of the trapezoid formula, if I don't know it, I'm checking my reference sheet, right? This is my trapezoid formula. I'm going to write it down. This is going to be B1, this is going to be B2, my height is the distance between the two bases. If the entire height's 4, then this height is 2 because I connected the middle of my sides. So that means it's going to be halfway for the height too. So I have 1/2 of 2 times 6 plus 9. And again, I don't care what calculator you use, you can do it either way. Using their calculator on your computer is going to save you some frustration from remembering your order of operations because you can just type it in exactly like it is. You can say 1/2 times 2 times 6 plus 9, and I typed it in exactly like it looks. So I don't have to worry about what order was I supposed to multiply or add. It does it for me, so I get 15. Okay, if you did it on your handheld calculator, you get the same answer, just have a couple extra steps to take. Right, number 24, we have an isosceles trapezoid. So it's important that we know it's isosceles because when it's isosceles, your base angles are congruent to each other. So that means if this angle is x, this is x. And if this is 2x plus 6, this is 2x plus 6. So the pair on the bottom and the pair on the top are the same size. Okay, it says, what is the measure of angle HIJ in degrees? So I want this angle right here because it goes HIJ. So I need to figure out x. I can do this 2 ways. If I know this has 4 angles, 4 sides, 4 angles, I know every time that happens, I get 360 degrees total, right? Just like a rectangle or a square, anything with 4 sides adds up to 360. I could do it that way. So one way to do this would be to say x plus 2x plus 6 plus 2x plus 6 equals 360. That's one way to do it. Another way to do it is if I remember my trapezoid properties, then I remember the consecutive angles that are between the bases, they make 180. So I could do it slightly shorter by saying this angle and this angle make 180. I'm going to get the same answer either way I do this problem, so it doesn't matter. This saves you time, but you have to remember that fact that the angles between the bases in a trapezoid make 180. This way gives me 3x plus 6 equals 180. I subtract the 6 from each side, and then I divide by 3 to get x is 58. Okay, that's not my answer yet. That's just x. I want to show you the other way just in case you wanted to do it that way. If I combine all my like terms, I have 1x, 1x, 2x, and 2x. That makes 6x total. And then I've got 6 and 6, which makes 12. I subtract the 12 from both sides. And then I would divide by 6 to get x is 58. Okay, so either way you do it, you get x is 58. Again, just like that other problem where we talked about where we solve for x, you have to read what the question wants you to do. I don't want x. You have to be really careful about this. Okay, because you might be excited, you're done, you got x. You have to plug x back in. So I have to say 2 times 58 plus 6. And again, whatever calculator you want to use, do 2 times 58 and add 6. Okay, and we get 122. So that is our answer for that question. Right, number 25. Rectangle G has a length of 15 inches and a width of 20 inches. So I'm drawing a picture because I need to think about what this looks like. 15 and 20. Rectangle, this is G. Rectangle H is similar to rectangle G and has a length of 18 feet. So draw my picture. This is H. Now I have to pay attention to what I made length and width. Here I called the 15 the length and I called the 20 the width. So in H, it says the length is 18. So I have to put the length in the same position that I put the length in G. What is the width of H? So this is the one I don't know. When we're dealing with similar figures, we want to make a proportion to help us find our missing piece. And there's more than one way we could set this up. Okay, I could do length over length, right? Length over length, and then width over width. That would work. I'm matching up the pieces that correspond to each other. So in this situation, I cross multiply, and I have 15W, and I cross multiply this way, and I get 360, and then I'm dividing. Okay, when I divide, I get 24. Okay, got the width, 24. That's one way to set it up. You might choose to do it differently. If I did length over width, so 15 over 20, and then I did length over width, I still get 15W equals 360, and I still get 24. So as long as you keep your corresponding parts lined up, you're okay. So either length over length and width over width like this, or you do length width, length width. Corresponding parts just have to be in the same positions. Okay.